Today we are solving a very simple looking LeetCode problem, self-dividing numbers. But this problem is important because it teaches one core DSA skill, how to break a number into digits and check conditions digit by digit. This exact idea appears again in problems like palindrome numbers, Armstrong number, digit sum, happy number and many number-based DSA questions. Given two integers left and right, we need to return all numbers in this range that are self-dividing numbers. A number is called self-dividing if it is divisible by each digit it contains. For example, take 128. 128 is self-dividing number because it has three digits, 1, 2 and 8. And each of the digit divides it completely without leaving any remainder. Since 128 is divisible by all its digits, it is a self-dividing number. But there is one important rule. A self-dividing number cannot contain the digit 0. Why? Because division by 0 is not allowed. So a self-dividing number cannot contain the digit 0 because let's say 107. So 107 mod 0 is not defined. So that's why a self-dividing number cannot contain the digit 0. Let's look at the first example. Left equal to 1, right equals 22. We need to check every number from 1 to 22. So numbers like 1, 2, 3, 4 till 9 all are self-dividing because they contain only one digit and their digit divides is divisible by itself. So numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9 are all self-dividing because each number has only one digit and is divisible by itself. Now take 10. Digits are 1 and 0. So 10 is not self-dividing because it contains 0. Now take 12. 12. So 12 is 12 modulo 1 equals 0 and 12 modulo 2 equals 0. So that means it is self-dividing. Take 15. 15 is also self-dividing. So 15 modulo 1 equals 0. 15 modulo 5 equals 0. So self-dividing. So therefore our output will be this. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 11, 12, 15 and 22 because both 2 and 2 divides 22. Now how do we solve this? We need two steps. First, go through every number from left to right. Two steps are there. First, we go through every number from left to right. And then second, for each number, check whether it is self-dividing or not. So the main question becomes, how do we check if a number is self-dividing? So this is the main question. So suppose the number is 128. So we need to first extract its digit one by one. In programming, we can do this by using modulo and integer division. So now extracting the digits. So first we do 128 modulo 10. That is equal to 8. So 8 is our unit digit. Now we do 128 double slash 10. This is integer division. So it gives us highest integer uh, greater than or equal to the quotient. That is 12. Now we do 12 modulo 10. This gives us the tens digit. Then we do 12 double slash 10, and this gives us 1. Finally, we do 1 modulo 10. This gives us the hundredths digit, and 1 double slash 10, that gives us 0, and we stop. So this is a very common digit extraction pattern. Now for every digit, we check two things. First, if the digit is 0, immediately return false. Second, if the original number is not divisible by the digit, return false. If all digits pass the check, then the number is self-dividing. So let's write down the pseudocode. Let's initialize our answer equal to empty array. Then for num from left to right, if is self-dividing, is a function which we will write now. So we add num to answer, and finally we return the answer. Now let's write down the function. Helper function is self-dividing. So we initialize original equal to num. Then while num is greater than 0, we do the digit extraction. So digit equal to num mod 10. If digit double equal to 0. So while doing digit extraction, we are also checking if the condition is fulfilled or not. So if digit is equal to 0, then we return the false directly. Or if the digit does not divide the number, then we return false. And if things are successful, then we move to the next digit. So and for that we divide the number by 10. Finally, we return true if the loop passes successfully. So this is our pseudocode. Now let's write down the code. We initialize the result. We run the main loop. Now we check if the number is self-dividing or not. So we give the ranges from left to right plus 1. Because in the range, left is included, but the second parameter is not included. And then we keep appending the result. Finally return the result. Now let's write down the helper function. So this takes one parameter basically. This is a class instance cell. The one parameter is num, and it returns a boolean value. So here we initialize original equal to num. Then while num is greater than 0, we run this loop, we extract the last digit. If digit equal to 0 or if digit does not divide the original number, then we return the false. And if both the cases passes, then we divide the number by 10, integer division by 10. Finally, if the loop passes successfully, we return true. That is, the number self-divides itself. So let's dry run this for 128. So num equal to 128, let's say. So in our original, 128 will be stored. Then digit will become equal to 8. Then num will be updated. So 8 does not divide, 8 is not 0. And 8 divides 128 mod 8 equals 0. So we make num equal to num double slash 10. So it becomes 12. Then digit equals to now 120 original, not num but original. 128 mod 2 equals 0. So now let's update the num equals 1. Then digit equals 1. 1 mod 128 mod 1 equals 0. So num will be updated, num will become 0 this time. And the loop ends. So true is returned. So 128 is self-dividing. Now let's do a dry run with a second dry run with an invalid number 120. Original is 120, num equals 120. Digit will become 0 and it will give false because of this condition. If digit equal to 0, then return false. So that is true. The dry run executes successfully. Now let's comment out the code and actually run the test cases. Okay, they passes. Before submitting it, let's discuss the time complexity. We are checking every number from left to right. For each number, we check its digits. So time complexity is of order n is the total numbers in the range star the digits that they have number of digits. Since the constraint is only up to 10 power 4, the constraint is only 10 power 4, so this is okay for us. This is very efficient. And space complexity is order 1 because we don't use any other array. We simply use a few variables. So now let's submit the code. Okay, so it is accepted. All the test cases pass. Now let's discuss the common mistakes. So it is very common that people generally use the changing num for divisibility check. We have to use the original number. We need to use original mod digit, not num mod digit. Because num keeps changing as we remove digits. Now common mistake number 2, forgetting to handle 0. If we forget this, we must immediately, if the digit is 0, we must immediately return false. Then common mistake number 3, using slash instead of double slash. So in Python, slash gives decimal division. To remove the last digit, we need integer division. Common mistake number 4, forgetting that the range is inclusive. We need range left comma right plus 1, not left comma right. So in this problem, we learned 4 important DSA concepts. First, how to iterate through a range. Second, how to extract digits using mod 10. Third, how to remove digits using double slash 10. Fourth, how to create a helper function to keep the code clean. This is a beginner-friendly problem, but the digit extraction pattern is extremely important and appears again and again in number-based DSA problems. That's it for LeetCode 728 self-dividing numbers. The main idea is simple. Check each number, extract each digit, reject if the digit is 0, and verify divisibility with every digit. If you understood this pattern, you have learned one of the most useful number processing techniques in DSA.